All right, everybody. Welcome to day 4. So for today's lecture, we're going to do a few things. We're going to go over the stuff that we looked at a little bit the stuff that we looked at in the last lecture. Figured out an alternative way to get past the debugging. If you remember last lecture, I had a bit of issue with debugging a file. It didn't seem to want to understand where the breakpoint was. It didn't seem to want to understand the classes, the methods, that kind of stuff. We took a look at it, fiddled around with some other settings and whatnot. Everything seemed to be there, but one extra trick that we use to resolve that issue might be able to help you should you run into it, because all the other techniques failed prior to that. So we'll go through and see a little bit of that in some of the stuff tonight, some of the stuff from last lecture. We'll be going through and introducing, or I'll be going through and introducing the concept of arrays, which are just a cluster of the stuff you've been working with so far. We'll look at how to get to a specific one of the things in that big mass of data that you're dealing with. We'll look at the ability to iterate over that big mass of data, just from the very beginning to the end, and just dump out all the information, or look for a specific one, etc. And then we'll be looking at the ability to create your own containers of data, so you can totally customize these things. You're not limited by whatever's built into the system. You can basically describe the object that you want to track. Okay. So, real quick refresh of day 3. We talked about serialized field. It's an attribute that you apply to a variable that you can then see and modify in the inspector. We talked about booleans. They use the same kind of syntax as far as declaration, definition, and assignment as the rest of the variables you've dealt with so far. We just swap out the word int or string or float for the word bool. B is the Hungarian notation prefix. And then we talked about how you can go through and use the not operator or the exclamation mark to invert whatever the current value is. So true is equal to not false. False is equal to not true. We looked at if, and else statements in terms of chaining together our rules and how to construct various gameplay scenarios. We looked at how to take two separate possible inputs and then govern, do I take this left branch or this right branch based on whatever I've decided. That would be the zombie door adventure. We looked at the syntax itself. If the first test scenario within these parentheses resolves to true, then whatever is inside the body of that first if would execute. If that is not true, then it jumps down to the optional else if right after that. Then it performs that test again, that if check for every subsequent one. And if every one of those above it fails, if you optionally have the else at the bottom, that's your default catch-all. We also looked at comparison and logical operators, going through and actually doing mathematical or equality or inequality checks against different things. We also looked at combining numerous tests together, not just in the same way that the if, else if can chain different decision points, but we also looked at inside those parentheses of the if, being able to perform multiple checks stitched together. So the left side and the right side must be true in order for this particular operation to happen. Same thing with the or. If one side or the other is true, then we're allowed to do whatever operation it is that we're looking to achieve. Went into a bit of debugging and talked about how up to this point, you've seen debug.log. That is a great way of getting the program to talk to you. It's the whole hello world thing. You can use that to saturate your code with logs, get all kinds of information. Problem is, that can actually be a performance hit if you have way too much of that information. If you're pumping out a lot of data, especially if it's in something like start, where it's hitting every single frame, the amount of overhead that it takes to take whatever it is you're wanting to view and dump that to a console, it can be substantial. You can drop a lot of frames by doing that. So we looked at the initial part of going in and using the serialized field with the inspector to see some of this data. We looked at how you can kind of pause Unity, the editor, to see what these values are, hitting the next frame to inspect it as it goes along. we started but didn't get too far into looking at breakpoints and how you can use Visual Studio to actually inspect the content as far as the code is concerned. So as we tear through today's lecture, we'll also look at the debugging as well. So we'll use that to inspect some of our variable arrays. Okay, so I'll further cover this when we actually get into the code, but basically the trick this time around is inside Visual Studio, if for some reason it's just not seeing your, let's see here, jump back to Unity and just open up a script or whatever so we can get back into Visual Studio. If for some reason this project that's built behind the scenes by Unity just fails to be understood, normally a restart will fix that. But sometimes, right here on the project itself that you see here in the Solution Explorer, if you right-click on that and go down to Unload Project, it'll dump everything. This project will be purged from the solution list. And if you reload that project, then any of the information inside these files that's not seen, not understood properly, will then be seen. Notice these two files just happen to be sitting outside of the scripts folder. That doesn't matter. It's as long as it's underneath the project, everything should work. So these little disclosure triangles here give me more information about the individual file. And this was noticeable by this first drop-down just underneath the tab. From last lecture's error, if you click that drop-down, it would say miscellaneous files. Well, this isn't a miscellaneous file. It's an actual integral part of this entire project. So I needed it to be seen. I needed those libraries to all connect and talk to each other. So by unloading the project, unload project, and reloading it, it basically re-scanned all of its files, and it found that, oh yes, this is part of my project. Go ahead and link all the stuff together. This mono behavior was previously white instead of this teal color. Debug.log was failing in different ways, so now everything should resolve. Worthwhile to possibly use that technique because it doesn't require restarting anything. If that works for you, awesome. And so we go from there, if not restarting, if this reset works. Okay, so I jump back over to the slide real quick. So we'll go into more of this in just a second when we actually get into the actual code. So up to now, you've been dealing with basic data types, ints, floats, bools, strings, that kind of stuff. But what would happen if you needed like an inventory, or let's say, you know, a bucket that could contain a bunch of these things, right? You have one integer, or maybe you need 10. Maybe you need 100, 1,000, several more. Well, would you in your code write int in1, int in2, int in3, and just keep doing that? No, because that would be a massive waste of time. It'd be a massive waste of space in terms of that file, because then your variables would just be this big long stack of stuff, and there's no need for it. It also makes it incredibly unwieldy in terms of updating in the future. I mean, imagine you decide you want to change the name of something. You want to refactor the way the code looks or works. I mean, having to go back through and manually update every one of those little individual instances would just be an absolute nightmare. So we realized as language designers back in the day, we as in the collective community of programmers, that you needed the ability to kind of cluster this data together. And so the concept of arrays was formulated. So the idea is it gives us, using a single name, just like a single identifier, just like we do with all of our other variables, bool, b something. In this case, that b something, well, we're dealing with arrays, so swap the b to a, so array, and now just name it something. And think of it in terms of plural, like it's a bucket of things. And so you do basically the same syntax as you would with all of your other variables up to this point, your declarations, definitions, assignments, except you add a couple more special characters, the square brackets. The square brackets alone give this bit of code the heads up that, hey, I'm not just one, I'm many. I'm a whole bunch of these particular things. So that very first example up there, A candy names, that's an array of strings. So I have the first string, a second string, a third string. I have any number of strings that I could eventually fill out. So, imagine if you cracked open something like Excel and you were looking at this big long list of things. Well, the first column, the A column, index 1 up at the top, 2, 3, 4, every one of those row cells, you go through and you add some special unique value. You could duplicate the value above it or whatever. The thing to keep in mind, though, is that programs, computers, they start at 0. They don't start at 1. So all of our variables up to this point, when we default them to 0, that also kind of plays in terms of this. So if you're looking at, well, what's my very first entry? It's not 1, it's 0, and that'll put you right up at the very beginning, the 0 address in terms of how this stuff is laid out in memory. And so you'll see more of this as we continue on and look at like how we can index these things, how we can iterate through them as we get into the square bracket information in the next couple of slides, as well as the for loops. But understand that the content inside these arrays is nothing more than just a collection of the things you've dealt with. So they all have their own internal defaults, and it's just opening up like a filing cabinet of a bunch of file folders. Which one am I talking to? They're all documents of some kind or bits of information, and so we scan through and find what we're looking for. So in terms of declaration, you just add the 2 square brackets. The thing to keep in mind about arrays is that you're basically telling it, I'm going to have like a placeholder. Now, imagine that's like, I don't know, a crumpled up bag, right? It's a bag, it can contain stuff, but it's crumpled up. There's no information in it whatsoever. You need to expand that bag before you can actually start putting stuff in it. So there's one more extra keyword that we use with or in conjunction with arrays, and that's called new. That's because we need to tell the environment that we're running in, or more specifically the operating system. The program talks to the operating system and says, I need a certain amount of space. If I'm dealing with strings or integers or my own custom data types, every one of those things potentially has its own size. And so up front, we don't really know that, but when we construct it and when the code gets compiled, the system says, okay, I understand that you need X amount of bytes for this stuff. So we ask it for a new bucket of this size so we can stick all this information into it. So for the first declaration, you'll always see that eventually followed up with some kind of new call. So underneath the definition, where we do the A candy names equals new string, where we give it some size, we're asking for 3 new strings. That's always going to be paired up with it somewhere. You don't just leave these things floating without new, because that'll actually crash. I'll demonstrate that here in just a second when we try to use a variable or try to index something that doesn't exist yet. So that's just one extra little step you have to be aware of, is these things won't work unless you've given it space to put the thing in it. So once we've actually, inflated our bag and we can stick stuff in this thing, then we can go through and we have a couple of different options. We have the definition where we can say inflate and also have this extra bit of information, or we can say just inflate it and we'll come along later on and fill it out. Now down there under assignment, you see that's coming along at some point and sticking the string lollipop inside index 2 of that array. So let's see here. To gain access to this stuff, I talked about how we always start counting from 0, and we're just looking at these numbers going forward. So this array would have 3, and if you go back to the previous slide, we can see that it's allocated right here. This A candy's name currently has 3 slots in it. Slot number 3, 0, 1, 2. We always basically subtract 1 in our head. Start counting from 0. 0, 1, 2 is the third index, or the third slot. So here I'm going to put this value into this array. And now later on, if I wanted to print that out, I could just say the A candy names square brackets and then some number, that'll pluck out that value, whatever it happens to be set to, and I can use it, I can debug log it, I can do pretty much anything with it. I could then come along and set it to something else if I wanted to. I could change it. So the next line down, you see an example of doing the same thing. Instead of with strings, we're doing it with integers, and these are the defaults built directly into it. So I automatically populate it with a 5, 4, and a 2. So then down here, I'm saying that I want to index. I want to get access to slot number 1. So up here, 0, 1. So I would be talking to this 4 on this second half of the line. Now, if you went back and you looked at whatever was populated here, all right, whatever 1 would be, that would be 0, 1, and then whatever that happens to be. So we'll see this in practice here in just a second. But this is generally the way the syntax works. You have your type, you have your square brackets, and then you have your identifier for it. Then you populate it or populate it later on. And when you do that, it's a two-step process. You get the space for it, and then you fill it with something. So new for the space, and then the curly brackets or the equals at some point to actually put data into it. Okay, so now we have this bag of stuff. It's all kinds of strings or integers or whatever. And the key takeaway here is that these all have to be the same type. Like you can't at this stage you can't mix those types. Can't be an array of both ints and strings and floats. It's all strings or all floats. And then maybe the next array over is an array of integers, or the next one over is an array of floats, that kind of stuff. But we need to be able to look at the content of this stuff. So we have this concept of a for loop. So we're going to iterate over some bit of data for a certain number of times. So you'll see up here that the syntax for this is just like what we saw with if statements, with methods when we created those. We have an identifier followed by a pair of parentheses followed by a pair of curly brackets. This stuff all kind of follows the same style. And so here, instead of the word if, or instead of the identifier, your name for a method, we swap out for the word for. Then inside that bit of code, we go a little bit more advanced. We say we're going to construct how we're going to look across this code. So if I want to just scan across for a certain number of times, I say start at this number, and while I don't meet this condition, continue hitting this loop, and then update whatever that counter is. So initialization, condition, and update. And you'll see this in practice here in just a second. Now, as we start dealing with arrays, you'll find that you can hard code this stuff. You can say, I'm going to have an array of 5, and then you can use 5 saturated through your code. It's a bad practice to get into. You don't want to hard code values throughout your code. You want to allow the system, either the compiler or at runtime, to kind of give you information. That makes your code a lot more flexible. So in this case, arrays have this neat little feature where I can simply ask it for its length. And regardless of what amount of information is in it, it's going to tell me, hey, I have 3 members, I have 10 members, 10,000 members, whatever. And I can automatically jam that value coming off of in this case, it would be the name of the array dot length. Now, length is a special thing that we're going to see at the end of this class that gives me certain information. It's kind of like a method, but it handles things a little bit differently, and we'll see that syntax in just a moment. And so to reiterate the way those brackets work is, as we're looping through this thing, that we start at 0, right? We define I being like our index, our iterator. We start at 0, and we run for as long as there are things to run over. And so you'll notice I'm using a less than comparison check. So I want to do this loop as long as I is not greater than or equal to the total number of things inside my array. So let's say there were 10 items in this array. We start at 0 because we always start counting at 0. It would then update with that I++ at the end. I showed you that a couple of lectures ago, where you can take the current value, add 1 to it, and store it in itself. This was last lecture. This was part of the zombie adventure down towards the very bottom. We can shorthand basically I equals I plus 1. So that update just basically says for every time I run this loop, just update, add 1 to I. And eventually what's going to happen is I, starting at 0, will go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 9 is less than the total number that we had, 10, so that one would run. But on the next update, I becomes 10. Well, is 10 less than 10? No. So that check, like an if statement, is false, which means that next run never occurs. So we break out of our for loop. We've completed it. So at that point, we would have run over all the content inside our array by simply using I to index whatever location in that big long array that we were scanning across. Okay, and the last thing we'll get into is taking those concepts, those basic data types that you've worked with so far in terms of integers, floats, strings, that kind of stuff, and build out much more complex systems. This is analogous to, we talked about calling methods, like calling debug log, and then you saw how to write it. So we've used all of these data types up to this point. Now with this concept, we're going to take all those things and we're going to create our own custom containers that are full of those variables and those variable types. And so we're going to store, just like programs in general have state and behavior, data and functionality, we're going to do the same thing. We're going to create our own containers that both have state and have behavior. We'll also be talking about how the other systems in your code, right, how they can talk to whatever it is you've created. Up till now, we've only been working in one single file. So all of our stuff is right there. But you've seen where if you create the variables up at the very top of the file, they can be seen by everybody. Start, update, your own custom methods. But if you create your variables inside those methods, start, update, your own methods, that isolates the lifetime of that particular variable. And so it's not available. If you declare it inside start, it won't be available over inside update. It just has to do with the lifespan and how these things jump from one section of code to the next. We control its scope. What you'll find is that as we start constructing other files, it would be interesting to see a single game written in one single file. That would be a massive file. In fact, the system will probably stop you because that's way too much data for a single file, and you hit some kind of limits on this system when it's trying to compile stuff. So we modularize, we componentize, we break out our game into a number of different modules, right? Little bits, just like methods, little bits of functionality kind of scattered about doing different things. You want to isolate down whatever something's going to do. And so you don't necessarily want like your player doing, flight dynamics. You'd maybe have some kind of a system doing that. So the idea is to break these things out and make them specialized. And so how do those things, whatever it is you've constructed, how do they talk to each other? We'll be going into that. Some of this information, you want to keep it secret. You don't want anybody else in your program to possibly mess with it because it can be damaged, right? You don't want it to be modified outside of your control. And so we'll take a look at how to go about doing that. Okay, so now that is a quick run through of the slides themselves. We're actually going to go into code and take a look at every single one of these things in much greater detail. So you can see what the syntax looks like. You can see pitfalls and also how to debug using Visual Studio and so on. Okay, so I'm going to stop this slide. I'm going to jump over to Unity. And first thing I want to do is create myself a new scene. So I'm going to do Control-N. Okay, create myself a new game object to put my script on. Then I'm going to create a new script. I'm going to call this Day 4. Okay, when that finishes compiling, I'm going to move that into my day 4 location, and actually get rid of that because we don't need it. That was just a test file. Okay, so on my game object that I created a second ago, I'm going to take this day 4 file and drag it over, drop it, save. In my scenes directory, I'm going to go ahead and call this day 4 and open that up in Visual Studio. Okay, very first thing I want to do is, and now notice a couple of things happened here. One, I did not get that usual pop-up to reload the project because it changed over on the Unity side. So this is the very first indicator that something about this file is actually incorrect. The second thing is there's no graying of this system collection generic, or my mono behavior or start or update. So I know that something about this is going wrong. So making sure that everything's okay over here. We've attached it. Cool. Jump back. Unload this project. Moment of truth. Let's see if this actually works. Hey, check it out. It's gone through and it's given me the proper information for this day 4 script. These two are grayed out compared to the lighter Unity engine. The teals come back and the colorings come back. So there's a live demo of this thing resetting itself. So, okay. Now, I want to talk to debug, and notice it comes back. My filtering list here is proper. So debug.log hello world. Okay, this is just to verify that it's functioning over here in Unity. See down here my console, hello world, excellent. Cool, so I'm gonna slide it back over a little bit. Clear it out. Okay, so now I don't need that log anymore. So I told you that from the very beginning we started dealing with these basic data types, ints, floats, bools, strings, etc. But making a whole bunch of these things would just be an absolute nightmare. So trying to maintain, int in 1, int in 2, so on and so forth would get really boring really quickly. Another thing, string S1, so on and so forth. If you ever see it, if you're dealing with the same basic data type, like here, integers, sometimes you can actually omit the semicolon to end that line and then going down to the next line for the same type. You can actually kind of squish that together. Shorthand in this case would be to just add a comma, get rid of the type. So in1 and in2 being integers, I'm just creating them. This comma syntax, you'll actually see this as we construct the variables that go into, the arguments that get passed in as default values for our array content. So it's actually useful to be aware that you don't have to explicitly say line 1, line 2, line 3, this is an int, this is an int, this is an int. You can kind of squish these things together. So generally speaking, this would be a nightmare to try to maintain, especially if you have this stuff scattered throughout your code. Trying to write some kind of I want to see all my variables. Having to manually write that out every single time would just be crazy. So what we do is we come through and say, I want a string and I want to call it, normally it would be candy names, right? This is all, the whole candy motif here is Halloween, So instead, we want to make this into an array. So the first thing, I'm going to give myself a heads up that this is no longer a string, this is an array. So I've swapped out the S for an A. And right after the word string, I want to add a couple of square brackets. So now, let's see, this has converted from a standard one single string to a potential array of strings. This can contain all kinds of number of strings. Okay. So we saw that if we wanted to actually use this, I would need to come through and allocate it. I need to take that crumpled up bag and inflate it so that I could stick stuff in it. So a candy names equals new. And we have to, for C#, we have to say what type it is again. And then we have the option of saying how many things we want in this just by default. So I can add the square brackets again. Notice this syntax here, string square brackets is the same over here on the left-hand side. So here I can just say I want to do 3 items inside. I want space for 3 strings inside this array. Okay? So now I need to actually fill it with information. So right now, if I, let's see here, debug log stop here. This is strictly for demonstration purposes. If I put a breakpoint on this log, actually, I'm going to go one step further. I'm going to go back up here to the top, line 14, put a breakpoint there. Now, to make sure this is all synchronized and proper, I want to jump back over to Unity now that I've constructed a number of things. I want to let it compile. That way it kind of keeps everything in a synchronized, updated order. I don't want to modify stuff, try to start debugging, and then step into Unity and have it start compiling stuff, because what it might be looking at, like you saw with the new files to a project, how that kind of got a little confused, sometimes that can happen here with Unity. So making sure that you've saved all your work, jump back to Unity, let it do its compiling, then start the process of debugging. Don't run while you're doing this either. If you're writing code over in Visual Studio, have Unity in not playing mode. Have it in stop mode. The idea is you won't be live reloading the code. Yes, it can support it, but sometimes that can generate some really bizarre errors. And so it's just good practice, just like I showed you in day 1, where I went through and showed the tint, the player tint. The idea is I don't want to be running while I'm actively working on code, just to avoid some rogue, inconsistent states. So in this case, we're not playing. We've allowed this thing to compile. Now, if I jump back over to Visual Studio, up here at the top center, I have attached to Unity. And when I click that, it basically tells Visual Studio to attach its debugger to Unity. Visual Studio to attach its debugger to Unity, so that whatever Unity is actively dealing with in terms of its code can be seen or debugged, inspected by Unity or by Visual Studio. So you'll notice the UI changed a bit. So I got a number of new buttons: pause, stop, reload, step in different ways. This is, I have taken control over the execution of my program. Meaning, if something goes awry, or if I specifically tell it to stop on one of these break points, meaning it stops, it breaks the code dead in its tracks, I can then say, cool, I've identified whatever logic in this line that I want. I've made sure that my variables, my assignments, etc., they're proper. Now I maybe want to test out the next line. So using those step commands, I can step to the next instruction. I can avoid a whole block of it by stepping over. If I'm running into a method, maybe I want to see something specific about that method, so I can step into it. And then I can continue on by hitting this. Let's see here. These will change to allow you to continue on. So right now, this is actively running. It's not paused. It's not in a breakpoint. But if I jump back over to Unity and hit play, very first thing that will happen is Unity is going to go, whoa, what's going on? And if you start trying to click around in Unity, you're going to notice it seems like the entire user interface is completely non-responsive, unresponsive to anything you're trying to do. Look at my taskbar. See how Visual Studio is flashing? That means it's taken focus, or it needs your attention. So if I start clicking around, I'm not getting any kind of responses. But if I jump back to Visual Studio, it has stopped the execution of both my game and Unity, the engine as a whole, waiting for me to continue, waiting for me to press the play button again. So in this case, you'll notice it's inside this little breakpoint icon over on the left-hand side, just to the left of 14, there's a little yellow arrow pointing. That's the current program, what's it called? Program, I forget. It's where the program is actually executing at that moment. It's the program counter, I think. And it means, like, as you're, just like humans, as we're reading code, we're reading a book, we're reading whatever, sentences, where our eyes are focusing, the word, the letters, that kind of stuff. The program, the operating system, is doing the same thing. It's executing your code in a very specific pattern. And so I have stopped the program counter, the line of execution is holding right there, giving me information about stuff around it, but then it's waiting for me to say, go ahead and continue running the program. So in this case, Visual Studio, being a rather powerful IDE, integrated development environment, gives me a lot of information, and there's tons of other stuff you can see in these various menus, other windows, not just Solution Explorer, breakpoints, and watch, but like locals, call stack, like there's a lot of stuff in here that you can use to really tear into your program should it be acting weird. So in this case, the breakpoints show me these two things that I've created, and this will pop up and show you other files. So if I have those day 1, 2, 3 files, if I had breakpoints over there, it would tell me day3.cs line whatever, there's a breakpoint there. Now I'm not actively running it, so it would never hit that breakpoint. But it's useful to know because you might have these things scattered across your program. So you might want to go from system A, which talks to system B, and then to system C. And you might want to know what the data is going through that chain of command, if you will. And so you are encouraged to look around at these different windows and see what exactly is being shown to you, what information is actually being given to you, because this is extremely useful. This also allows me to completely bypass a lot of that debug log stuff. I can set up, these breakpoints are actually a lot more powerful than just stopping here. I can tell it to stop if a certain condition happens, if some variable has changed to something else. I can say run this 10 times and then stop on this breakpoint. So you have a number of bits of control as far as like how they're constructed, what they're stopping on conditions right there. So so let's say I wanted to look at this A candy's name. I wanted to see what's actually going on with that variable. Number one, it's declared just a few lines up on line 10, but it doesn't have any information in it. The actual inflation happens on the line that I'm currently sitting on. So I can inspect what it was, what it is right now, what it will be once I've done the inflation, and then I can take a look at like actually assigning values into it. So I have a couple of options in Visual Studio as far as how to do that. So remember when we talked about scope, global versus local, looking inside the curly brackets and whatnot, this little space here, that block of code, is what's referred to as the local scope, which, if I look down here in my windows, I have a little tab called locals. So if I click on that, I see that I actually have a lot more information about this. In this case, it's giving me all the information about this whole file. But the idea is, if you wanted to inspect some specific thing, you would one of two ways. You'd have to either manually copy this or actually type it in, A candy names, right? You'd have to manually type it in there, or, right, null. Or if you check out the locals window, all this stuff is populated automatically. It sees everything in the file. Sometimes that's just a bit too much information depending on what you're trying to do. So you might want to focus on one specific variable, which is what watch does. It allows you to view a specific variable. Now, you can also mouse over any of this stuff, and it's going to tell you in the little pop-up what it sees for the context of that specific variable. So in this case, I see that my A candy names is currently null. Well, that's because when I created this thing, it's not set to anything. It is like 0, but null has a little bit more depth to it. So when I inflate this by saying I want to get new I want to get 3 new slots for some upcoming candy information. If I come up here, if I press continue, it's going to run to the next breakpoint. It's going to just execute, 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 and then stop when it hits the next one. But I can manually control that by using the step into, over, and out of. And in this case, I want to step, let's see here, let's go a step over to the next one, right? Because there's no method to step into. I don't want to step out of start. I want to step over to the next variable. Now it's stopping on my next breakpoint. Now if I hover over, if I put my mouse, my cursor over a candy names, notice it now changed from a null to a system string 3. Notice it also gave me this little disclosure triangle. So if I just mouse over that, I didn't even have to click. I go through and I see I actually have 3 empty, or actually these aren't empty, these are null. Null and empty are 2 different things. I have 3 placeholders for strings that need to be set to values. So I can then come down here. My watch, you see here, it updated in the same way. Value became system string. I get this little drop down, so I see more information. If I go back to locals, I see here off the variable named a candy names, I see the value of the type, the type of the array itself, and then I can hit the disclosure triangle again and see the information in here. And you notice we start counting at 0, then 1, 2. That's the index for each of these spots. Okay, so now I can, by the way, if you try jumping back to Unity at this point, I just tried swinging back over to it, it will fail because Unity is paused. Unity is waiting for Visual Studio to return control back to it. So back here inside Visual Studio, if I just say continue, I then get sent back to Unity because that's what I was actively working on a second ago. Okay, cool. So now I can stop running, and by the way, this is still attached. I'm still actively debugging. So I could hit play again and be sent right back to debugging the same bit of code. So if you accidentally run past some calculation you really wanted to check out, you could stop debugging or rather continue, and then from Unity start playing again, because you're actively still monitoring the same systems, the same code. Okay, so in this case, I'm done debugging these variables, so I'm going to stop, which reverts my UI back to its former layout. I don't need these breakpoints anymore, so I can just click on them to get rid of them. And by the way, those windows that you saw, like debug and local and that kind of stuff, they're still, or they should still be available if you go looking through view, and sometimes window might have a few over here. But a lot of that stuff is still available. It's just like it's contextual. It knows if you're playing, you probably don't want this information, but if you're debugging, then you do. So it sets itself up accordingly based on the context of what you're doing. So now if I jump back to Unity, it's still playing, so I can go ahead and stop. Okay, so that showed you that I've inflated the bag. I now have slots for that information. But now I need to actually give it some kind of information. So I want to say a candy names, and I want to access the very first in that big long array. I know I have 3 total, but using the square brackets is how I index directly into that array. I said I want the very first one, which is index 0. And I want to assign it to, let's go with Snickers. Okay, let's do the same thing for the next index. And if I accidentally use 0 again, I overwrite the value that I just assigned. Okay, and let's assign this to nerds. And one more to fill out this entire array. And let's assign this to lollipop. Okay, so if I was to play now and inspect these, every one of those slots, instead of saying null, would say these individual string names. Okay, but in this case, I don't want to go back through that process of debugging it. I want to actually print this information out. So in the same way we use the square brackets and a number to index regarding assigning it to something, we can also use that exact same syntax, the square brackets and a number, to query it, to get the information that exists inside that specific spot. So I want to go through and say debug log and just say first. And using string concatenation, I'm going to add a candy names sub 0. Okay, and if I save this, jump back to Unity and play. Stop here, we'll then swap out and say first is Snickers. So it's printing out exactly what was in the very first slide. Now, that's cool for the very first value or any other individual value, but let's say I want to see all these things. So this is where we start looking at for loops, the ability to scan, the ability to start at any point, doesn't have to be the beginning, and run across our data. So to do that, I'm going to drop down and say for, and just like with an if, just like with a method call, we throw into parentheses. And now you saw a second ago in the slides that I needed 3 parts. Those 3 parts, as part of a for loop, are separated by semicolons because they're individual statements. We do some kind of initialization, then we do some kind of conditional, which is checked every single iteration of this for loop, and then we do some kind of an update. So for loops, you are always guaranteed to have the keyword for, a pair of parentheses, and 2 semicolons. Whatever the data is between those semicolons, those 3 slots between the semicolons, matters for each of those scenarios, the initialization, the conditional, and the update. And I can, for the example I'm going to give you here, it's a very straightforward just counter, but you can add all kinds of other things in there. You can do multiple updates. You can make a single for loop actually count 2 different ways if you wanted to start at one end of the array with like I, int I, or and at the very end of the array, like assigning j to the end of it. And you can make I go one way and j go the other, meet or cross in the center. You have total control of this stuff, and you'll sometimes see this in some various examples, because why write 2 separate instruction loops to do the exact same core logic if I can do the same thing inside one? Sometimes you may actually have to write 2 separate things or more inside one single block just because of what has to happen for that particular bit of code. So in this case, for this for loop, I want to start out with some variable. In this case, I need to use an integer because that's what will be, when you're dealing with square brackets, the number inside needs to be an integer. It can't be a float because there's no such thing as halfway between index 1 and index 2. So in this case, I'm going to use an integer as my general counter. And generally speaking, when you see for loops taught anywhere, it's usually int I equals something. I being our index, our iterator, our counter. Sometimes it'll be like I CTR as I counter or something like that. In counter, so on and so forth. But basically this number just gets counted up. That's all it does. That's its purpose. So I, and I'm going to assign it to, or in this case I'm going to define it to 0 right off the bat. It's worth noting that you could feed other, like if you already have a counter somewhere, you could actually slot that in here. You don't have to redeclare what's going on. If you already have something and you're actively counting it, you don't need to reassign it either. You can actually omit this little spot. As long as that semicolon's there, it basically says there's no code to execute. And if you're not careful, if you do something like this, right? This code says start with whatever, check for whatever, and update for whatever. That will run for eternity. That's an infinite loop. So we add these conditionals as some kind of a way of giving us the ability to break out. So in this case, I want to use a counter, and I only want to run up for a certain number of counts. and then my loop is over. So going back to what I had a second ago, I want to say int I equals 0. The middle spot, the conditional, I want to say I want to do this loop while my I counter is less than the total number of things that my array currently has. So a candy names dot length, and length is the shortcut to how many things are inside this array. And then I want to finalize this by saying increase that I by 1 for every time we finish this loop. We come back around and then we do the conditional all over again. So the first little block, the initialization, happens one time. The conditional happens every single time, and the update happens every single time. Okay? So just like a method, just like an if, we need the curly brackets to give it a body. And inside the body, I want to say debug.log. And in this case, I just want to dump out the a candy names sub I, and that's it. Okay, so if I save, jump back to Unity, and play, I should get, let's see here, I get my first for Snickers, and then I get just a single printout for each of those next 3 lines. So it iterates over it 3 times and prints those 3 strings. Okay, so stopping play. So I also showed that, so what I've created here, I've declared up there on line number 10 that I'm going to have an array of strings at some point. Line number 14, I say I need to inflate the bag to a size of 3 so I can stick 3 things in it. And then I say, here are those 3 individual values. Now, what do you think would happen if I, instead of paying close attention to the fact that there are only 3 slots of this thing, if I went ahead and said a candy names sub 3, and I tried to assign this to something, what do you think is going to happen? Probably going to touch some memory out there that it shouldn't, and as a result blow up. So this program would actually crash. But because we're running in the editor and because it's smart about this stuff, it gives us a heads up. Hey, you're touching something. You've crashed the program if this was live. So probably go ahead and fix that. So in this case, it's telling me that the index that I just punched in, number 3, is outside of the range, the valid range of that little buffer that I created a second ago. So I said there are 3, and I just overflowed it by 1. So when I'm dealing with this kind of stuff, if I just double-click on this error message, it'll take me to, usually, the offending line. And in this case, it's saying, hey, this is the line that's wrong. If I was debugging this, regardless of whether or not I had a breakpoint or not, Visual Studio would stop dead in its tracks on this line and say, there's a problem here. So basically the same error you saw over in Unity. Okay? So I can stop. Yeah, I can stop playing, jump back over to my code. So now I don't want this offending bit of code, so just turn that off. But that is something to watch out for. So in this case, instead of something, it was index out of range exception. Okay? So now these 3 pieces, the declaration, the allocation, giving yourself the, I need to allocate a certain, I need to inflate the bag. The word there is allocation. And then the actual values for those 3 items, that's a little bit verbose. There's a lot of words there. Well, what if I can just wrap all that stuff up inside just one single line of code? Well, I can absolutely do that. If I come down here, I can say, in this case, I want to deal with like integers. So if I start out with an integer, in candy counts, okay, well now I know that I want to turn this into an array. So the first thing I do, change that into an A to signify that it's an array, and add my square brackets. Okay? Now, I want to go ahead and not just declare that it's there, but I want to inflate it as well. So add that new int square brackets. And instead of adding a number inside this little spot here, I want to leave that alone. I want to let the compiler or the runtime look at what I've written and give me that value automatically. Just like how length gives you the automatic count of what's going on, here I don't want to manually step in and say this thing has X number and then I manually fill it in. I'm just going to leave that alone. The compiler is smart enough to figure out what I'm about to write. And so just like with ifs, fors, methods, you need a body because you're going to be dealing with multiple variables at this point. And just like always, we end this thing with a semicolon because this is a whole line of code. And now the syntax for doing this is to simply write in like 5, 4, and 2. So it knows to start a variable called candy counts, give it a size. In this case, it counts up 1, 2, 3 things, and automatically populate it with those 3 variables. So to see that in action, if I do for int I equals 0, and the reason I'm able to do this is because, like we talked about with scope and lifespan, lifetime of a thing, this I that was created right up here, it's not being reused down here. It actually dies when this for loop finishes running. So I can reuse that variable. And in this case, I want to go ahead and say int I, let's see here, it goes I less than a candy. And here I want to make sure I'm picking the right type. So even though these two arrays will return an integer of length, maybe I'm tracking 2 different bits of information. Maybe I have like 3 characters running around my scene and I'm tracking the amount of candy each one collects. And so if I'm doing math in a certain way, maybe I'm accidentally asking the wrong array for its information. So this kind of attention to detail is critical, making sure that your variables are the ones you're actively intending to talk to. So in this case, I want the candy counts, and just like we did before, I to index it. Or sorry, I'm off by 1 line. So dot length, and then I to increase that counter. Okay, drop down, give it a pair of curly brackets for its body, and inside the body, let's go ahead and say debug log. And in this particular case, I'm going to demonstrate crossing the boundary. I have 2 arrays right now who both happen to have 3 lengths to them. The first one is that string array. The next one is this count. So I want to say a candy names, use the same index, use string concatenation to add myself a space, string concatenation again to add the next piece of this puzzle, and now I'm going to reference the count that I just created. So a candy count sub I. Okay, so now if I save this, jump back to Unity, and 1 second, I want to get rid of that. Okay. So now if I run it, I should see if I scroll back up, I see the first Snickers printout, I see the next 3 from that second for loop, and now I have Snickers 5, Nerds 4, Lollipop 2. And these, if I double click on it, takes me back to this location. So what you're seeing is this for loop referencing both this array up here at the top as well as this array created right here. So 2 different ways of constructing and populating those two variables. So like I said earlier, you've now seen arrays and for loops to be able to iterate over them. But let's say you want to go much more complex. You want to have like an NPC or some kind of a weapon or some kind of anything really. And inside it, maybe you need to track a name, hit points, a number of items in an inventory. You want to contain all this information. Well, conceptually speaking, instead of having multiple arrays of like an array of strings for my players' names, an array of integers for my hit points, an array of another int for items in my inventory or percentages or something like that, and then trying to use something like I here to actively jump between those multiple arrays. Instead of trying to track that kind of information, what you can do is say, well, I know that I'm looking at a room full of individual NPCs. Each one is going to have a name, a hit points count, a number of items in their inventory. That's all isolated to them and them alone. So the other approach to this is to go ahead and create yourself a custom data type that you can squish all this information into. So to do that, we have, let's see here. I need to go, let's see here. All this code that I wrote earlier, I'm just going to go ahead and comment it out. All right, so you can still reference it later on, but it's gone for all intents and purposes. So actually, okay, so void start. Okay, so to take whatever information it is and stick it somewhere else, I need some kind of a container. This container is what's referred to as a class. I'm going to identify a class of thing, all right? It's a descriptor, it's a label. So in this case, I'm going to go ahead and say save, jump back over to Unity, because I want Unity to be able to create me this file. So I'll stop running, clear. And now down here we have day 4, that's the stuff I've been working in. I want to go ahead and right-click, create new, C# script, and I'm going to call this, because I've been dealing with candy throughout this entire thing, I'm just going to go ahead and call this candy. Okay, when it finishes compiling, I'll drop that right inside my scripts location and double-click it to open. Now, here's the good stuff. Reload the solution. Should be the good stuff. Maybe not. Okay. Well, I'm going to unload the project, reload the project. So in Candy, the thing about Candy is I just want it to be a container. So I don't need any extra Unity specific stuff. Those 3 using statements at the top, the start, the update, the mono behavior, none of that stuff is necessary for this just container class. So I can clean that up, by surgically getting rid of each of these individual spots, or because I know for a fact that I'm just going to need public class candy, just going to go ahead and copy that, select everything in this file, delete it, and now paste that public class candy back in. Now I'm going to give myself the curly brackets to give this class its scope, its body. And now, like I said, I want to be able to track like a name and an integer for like the count or something like that. So in this particular example, what I'm going to do is go through and say this candy is like, Snickers or Nerds or whatever, and then the count is how many of those things I have. And then I'm going to create an array representative of my candy bucket, and it's going to have how many number of Nerds, how many number of Snickers bars, etc. inside it. And so to start out with, I want to say I know I need a name, so S name, and I know I need some kind of a counter, so in count. Okay, so that gives me all the information that I would want. But The thing about writing this kind of stuff is you tend to want to make sure that your data, your functionality and whatnot, it's secret. The other scripts, you don't want other systems to be able to just say, hey, I'm going to access your bucket and fiddle around with stuff in it, or I'm going to access the candy and fiddle around with it. You want to keep this stuff private. Now, by default, when Unity Unity creates this stuff, your variables are private. Your methods are private. You notice every so often throughout the class when I delete, start, or update and I retype it and I use the shorthand, it automatically slaps that word private on the beginning of it. What that's by default saying is that nobody else outside of this particular scope of this file can talk to it. So it does the same thing here with variables. And the idea is you want this as like a secret data location. You don't want the rest of the outside world to be able to fiddle with it directly. So you can go and write like a get this method, get this variable method to say return that thing, or set it. You can write a setter and set it to some incoming value. But the way C#, the general design paradigm here is that much like length, you notice length gave me a number, the count of the array, but I didn't call it like I would like debug log or something. I didn't use parentheses at the end of it. So that's what's called a property. The property has the ability to act like a method, so I can have functionality inside it, but it usually deals only with that one specific private variable. Now the idea here is that I could set these, like for example, let's see here. Okay, so now that I have my class, let's just say, for example, that I wanted to just deal with this information. So to access this stuff, I have to give it visible rights to the outside world. Now, if I save and I jump back to my day 4 script, and I come down, let's see here. Maybe. See. So inside my day 4 script, if I jump back up here, let's go below all this commenting, and I say I want a candy class called C. Okay. Now, you would think this is just like any other variable, int, in, variable, whatever. I'm just saying the type. In this case, it's what I just created over here, candy. So I should be able to say C, and in this case, I know it's a container, so I want to get access to those two things that are inside it. The thing is, if I press the period, you notice there's not a lot of information. So what's going on? Well, this is the access modifier stuff. This is locking down the data inside that class. Now, I could jump over here to my candy class and slap on the words public in front of both of these things. But that will give the outside world direct access to my variables. And I don't necessarily want to do that. So if I press the period again, you'll notice I now have 2 extra variables in this list, string and name. Okay, cool. So now I can set it to be, or actually, the name of my first candy is Snickers. Okay, cool. Well, if I tried to log this, or if I try to assign it, or if I try to do anything, if I save, jump back to Unity, remember how I talked about when I create an array, I need to inflate it, then I can stick information in it? If I try to run this, boom. I also crashed my program because I've not inflated it. I just have kind of a heads-up placeholder that this is my candy object, but because it's a more complex data type, it's got more stuff in it, the system needs to know I need to allocate the space for it. So integers, floats, strings, those are basic data types. They exist in the system, but something we create, we need to give it that heads up, like I need space for this thing that I just described, because it didn't have a heads up going forward. So I can stop playing, jump back over to my code here, and so let's see here. Where is... Give me 1 second. Okay, so basically to get around that, I need to allocate, I need to inflate that class. So I would basically come through and say C, just like I did with the arrays, I need to apply a new, but in this case I would say new candy, right? That's the type that I want to get access to. But there's a little bit of a caveat here. You actually have to tell the class like how it would be constructed. This is just rules of how this language and whatnot actually functions. So the way you do that, if I jump back to my candy class, let's see here, okay, so to get around that, I need to actually go through and say, here's how you would construct this thing. This is what's called a constructor. It's very similar in syntax to like methods. It's a special kind of method that says when I create this object or an array of these objects, here's what your actual values are, right? I'm going to construct it in such a way. So the syntax for that is public, right? Because I need to be able to call this from the outside world. All this stuff you saw up here, these public, by default is private. And now, when I actually call this, it's going to be the same name of the class. There's nothing special about that. So just like I said, new int, this is new candy. Okay? And like I said, it's just like a method. So there are the parentheses and the curly brackets right after that. So saving this, jumping back to day 4, I can add parentheses at the end here. And now if I save and run this, this error goes away because I'm no longer accessing an object that didn't exist yet. Okay? So, as I said, you don't really want to expose your private information out there to the world. You want some kind of a bulwark against that, some kind of a gatekeeper that can interact, that can sanitize the information coming and going. This is just a best practices data handling kind of thing. So I actually don't want the public on either of my private variables. So getting rid of that. Now the code's going to complain because it no longer has direct access to this S name. Okay, that's fine. I totally expected that. So I need to replace it. I need to give it some kind of an ability to actually fiddle with those values. So what I can do, I have a couple of different options here. I can right-click on the variable's name, do quick actions and refactoring, and in this case, I want to use encapsulate field. And use the second one, which is going to give me all of this green highlighted code here in this file. This other one references the external thing if it wanted to modify it. So in this case, clicking that button gives me all of this extra information. Now, when you're dealing with properties, sometimes you want to trim this up and make it look a little better, so I don't want that leading S at the very beginning. But notice when I highlight this, it's the only one highlighted here. If I select S name, these other ones are highlighted and it goes back up to this top one. Cool. So now I want to do the same thing for count. Right click on it, go to quick actions, pick the second one, and scroll down. Same thing, I want to get rid of this leading in. Cool. Now the idea here is that instead of calling directly to S name or S count from my other script over here, I would call these public accessors coming off the property. Now, the system is smart enough to understand if you put the equals on one side or the other, you mean to either assign it or you mean to query it, to get it and then to use it. So in this case, if I do over here inside this code, right, if I get rid of that, that leading S and just say name, what this is saying is set, right? Set name equal to Snickers. If I jump back to the code and I look at name, name's set calls, this is the block that gets called. Now, value is a built-in type. It's whatever the incoming type is. It's modified by the system itself. So string, value will be string. If it's down here with count, it'll be, value here will be integer. So what this allows me to do is a little bit of like sanity checking. If I wanted to, let's say this thing represented hit points, and I didn't want my character to fall into a bunch of spikes and whatnot, and then get blown up, and then, get a boulder dropped on him, and then suddenly have its health points drop below 0, I can go in and say, like, as long as the health doesn't drop below something, or I can reinforce that the string coming in actually has a value. I don't want to set this thing to nothing. So just for example, I can add some of those conditionals that we talked about in last lecture to go through and say if the incoming value is equal to nothing, then I can throw up some kind of an alert and say debug, not that, debug log. Note, it's not giving me information about debug log because I deleted all the Unity related stuff from this file. Now, to get around that, all I need to do is right click on, or if I mouse over it, I get this show potential fixes. All right, so right clicking, quick action, maybe not. Okay, so mousing over it, show potential fixes. In this case, I want to talk to the debug class and log method that exists over here inside the Unity engine. So I'm just going to pick this first one. And by doing that, if I scroll back up, it adds automatically this line number 1 using Unity engine. So quick way of resolving that. So in this case, if I get this an empty incoming string, I need to say Candy's name cannot be blank. And like you saw with methods and returning and kind of early aborting from your method, I can just say return to get myself out of this scenario. That way I don't assign, I've given myself the visual heads up that I need to fix something, and I've also not actually done the assignment. Okay? So now if I jump back over here, I can, let's see here, if I do debug.log c.name, this will call the getter. And if I right click on this and say, let's see here, go to definition, it'll take me to who I'm calling, and then I know that the equals, or rather just the act of getting it, right? c.name, I'm going to request what that value is. So if I jump back to Unity, let that compile, and play, I should see Snickers because I created the class, inflated it, assigned using the property, assigned that private variable to the word Snickers, and then I used the public getter off of the property, the public get accessor, to display it. Okay, so give me 1 second here. One thing to be aware of as you're writing properties just in general is pay very close attention to the name of the property that's being called out by the public, whoever's out there in public calling it, and then the name of your variable. If you accidentally write the same variable both in the property name up there and in either one of the getter and setter, what will happen is the system says, okay, I'm going to call this property, and then I'm going to either get or set, and when it sees the name same as the top, the top property name, it's going to say, oh, I need to either get or set, depending on what you're trying to do. Then it's going to see its name again. It needs to get or set, see its name again, see its name again, see its name again, and get into an infinite loop, an infinite recursive loop that will blow up your program in a fraction of a second. There's, generally speaking, as we execute this stuff, there's a certain amount of limitation as far as like how many thousands of times these things can actually be chained together. And if you exceed that, you get what's called a stack overflow, because you've blown past the amount of information that particular call can actually do. And so by basically telling it to infinitely call itself, it doesn't understand what's going on and just crashes. So pay extra close attention to that. Visual Studio is going to give you the ability, if you select it, it'll highlight what's going on. So just using like, oh, I know for a fact now that this name and this S name, they are different. So you can, just use that as a secondary sanity check. If you start playing Unity, if you jump into Unity, start playing, and it immediately crashes, that's usually your culprit. So jump back into your code, verify that you're not actually accidentally calling the wrong thing. Okay, so now you've seen that I have the ability to access name and count from the outside world using these properties to both get it and set it. But that's extra code. I actually have to create myself a new C, a new candy object, and then C dot something, C dot name, C dot count, and assign it to some variable. Well, we have the ability to construct these things just at construction time. So that constructor that I created right here, line number 8, candy, actually doesn't do anything other than allows for new to create myself the object. But what if I want to default whatever S name and in count up there at the top were, and didn't want to touch the properties? Properties can be used later on for updating and changing and setting and getting and that kind of stuff. But let's say I want to initialize these things to some specific sets of values. Well, I can use the constructor in a different way than just saying, here's a new version of me or whatever. So to do that, I can come up here and inside the body, just like every other bit of code we've done so far, I can actually say, S name equals something, in count equals something else. I have that ability. But what if I want to actually, like a method? Remember, I said the constructor is like a method. So I have the ability to come in and say, you actually can bring in information to then be used. So if I say that I want to bring in and some variable called S name, it's a string, and then some other variable called in count, I can do that. Now, you may notice that as I'm selecting these two words, I'm also being told, hey, these are the things that I'm setting. So I'm setting the incoming value to something different, or the incoming variable to something different. Well, that's not what I want. So I have two options here that can basically save me from myself. I can either get rid of the leading indicator, so I'm not talking to the private variable at this point. I'm actually talking to the property, triggering the set to fill it in with something else. And in this case, if I kept this code right here, I would trigger this error log to myself. Instead, I want to bring in the incoming S name, and instead of 555, I want to say in count. And notice this little green underscore that popped up, and it said, hey, you're assigning the same variable to itself. Are you sure that's what you want to do? In this case, no. It's strictly for demonstration purposes, so I want to get rid of that in at the beginning of the first call. And in this case, I would be triggering the setter of the count property down here. And Visual Studio is highlighting them, telling me which one it's actually talking to. Now, we'll see this more as we continue on, but there's a way of saying this particular instance of candy versus the next one over. So like I have Snickers, and then I'll have nerds, and then I'll have so on and so forth. Well, how do I talk to this particular thing? you have a predefined, a reserved keyword, just like all these other blue ones in the system, called this. And it literally means this instance. So what I could also do, just as a quick kind of, I don't want to necessarily go through all the stuff that my property does. I can actually say this to talk to this class, this instance, dot, and now notice I have all the methods and properties and variables that are inside this class itself. So now I want to talk to the in count. Okay, so now I am no longer talking to the property, so any kind of safeguards that I built in down there, just like I did with the name with value, those don't get called. But I'm now talking, when I select it, talking to this private variable up here at the top. If I select this in count, it tells me that I'm actually talking to this incoming parameter. So you'll notice that the only difference between these two words in terms of their spelling, there is no difference whatsoever, but it's what I'm prefixing this with. I'm saying the in count that's part of this class, which is actually different than the in count coming in. So that's another way if you wanted to retain this kind of similar naming convention to outside scripts versus this interior script. Okay, so let's see here. So now I've created a container that currently stores both a string and a count. I've got the ability to customize it as soon as I create it. I've got the ability to both get it and set it, those variables, from later on if I so chose. But now, because I've done that, because I modified the constructor, if I go back to my day 4, you'll notice Candy here is actually complaining. Something about this is wrong. It doesn't match. Now, if I mouse over Candy, it's going to say there are no arguments given to the that correspond with the required formal parameters, name, and it would eventually say, like, you know, integer and that kind of stuff. It's basically telling me that the signature of this call doesn't match the signature that exists over inside my class. The constructor does not match. And that's because if I come through here and I say Candy, oops, nope, can't do that. That's because if I start out here, right, just like new integer, assign it to, like with an array, using the syntax, if I hover over, it's going to tell me, like, see the very first line, let's see, the teal candy dot candy, and then in the parentheses s name and in count. That's what's expected. There are no other versions of this. And if you look at other methods out there like log, you know, debug.log, if you mouse over it, it's going to tell you, or some of these other ones that are random.range from the zombie example. If you mouse over the range method, it'll tell you there are multiple versions of one that takes floats, one that takes ints. So you can customize this stuff going forward. It's a more advanced topic, but it's there. So in this case, I know because I just changed Candy's constructor to take in a string and an int, I need to make that modification here as well. So now, instead of doing this c.name equals Snickers, I can just take Snickers, copy it, and inside starting a parenthesis, just like a method call, paste that in, and let's say 555 is my total count of Snickers. It's a lot of Snickers. So now I don't need that next line. And if I save, jump back to Unity, and if I clear that and run one more time, you'll see that I get Snickers again. Okay, that's cool, but, and I mean, I can, just like accessing the array information up here, I could go through and do these accessors all day long and start kind of constructing my stuff, my printouts. But I said at the beginning of class that classes contain both state and behavior, data, functionality. They can do stuff. So if I'm going to constantly be printing out the information that I currently store inside my class, wouldn't it be nice if I could just have like one single method that I could call and have it do that work for me instead of having to manually update all this extra stuff, all this extra code to dump this stuff out? Well, I can jump back to Candy, And let's say after the properties, I'm just going to go ahead and I'm going to create myself a method called void report contents. Okay. Now I don't want to return anything. I just want to right here in line. Nope. Right here in line, I want to say debug.log and let's say name and add the name that I have up at the top. So I could either say sname or I could call the property, in this case, name. That would trigger the getter, not the setter, because it's returning me the value. So here, let me just go ahead and do the variable itself plus just a space and say count and then plus in count. Okay. Now this will dump out the name and the count. Cool. So let's jump back over to Candy, and instead of doing this debug log, let's call out to candies dot well, I don't seem to see that method that I just created. Well, in the exact same vein as count being visible and name being visible, in this case, notice it's not sname and it's not inname. I'm talking to the properties here. And if I select over it, see the tooltip? No, okay. So if I select it, you'll notice the tooltip says I'm talking to the count, and this get set is what gives it away that it's a property, and the fact that it returns the type here in the beginning. So it's kind of like a method, but it just gets rid of, it omits the parentheses and the parameters in favor of the keywords get, set, and value. Okay, so in this case, to use that method that I just created right now, just like start, just like update, when you erase those and put them back in using Visual Studio, it slaps private right at the beginning. This data is actually, this method is actually private to the outside world. So my day 4 script doesn't know it exists. This is what allows me to keep functionality isolated, to encapsulate it away and, protect it basically. So I don't necessarily want anybody calling this. In this particular example, I'm fine with it. So I need to, just like my variables, just like those two properties, I need to slap the word public right on the beginning. Save that, jump back to the day 4 script, and now if I do my dot accessor again, I now have report contents listed down here at the bottom. So if I select that, enter, it's a method, so I need to do the parentheses, and then semicolon. That is a call to the method that lives inside this C candy object. So if I right click on this, I can go to definition, and it tells me this is what will be called. Okay, so jumping back to the day 4 script, jumping back to Unity, let that compile and play. And now I should get name Snickers count 555. The class is now responsible for telling the world about itself. I just say, hey class, tell us about yourself. So now that I've got the ability to both create and set in all one operation and manipulate the data that's inside my class and have the class go above and beyond its individual properties and report some extra data, right, that I've just gone in and customized how this is going to be printed out. Now I can go through and start constructing more elaborate candy items that would then get stuffed into the bucket. So to do that, we already saw that I'm creating just a single, where's my mouse? There it is. I'm creating just a single standard, just one candy object right here. This is no different than int I equals 0. But you'll notice actually a couple of, one extra little thing here. If I, instead of doing this C candy up here, right, if I comment this out and I do, what was it? Candy here, right? and I try to set it to something, but I don't allocate it, you'll notice that C actually gives me a little red underscore error indicator. That's because this C, even though it's created there, it's not inflated, none of the information inside it exists, and if I try to touch it in any way, it would crash my program. In this particular example, if I save this and jump back to Unity, it will prevent me from compiling. So be aware that when you're creating classes, the location can also be a little misleading. If you declare it up globally, you're basically telling the program, I will eventually fill you out. And it doesn't know when you'll do that. But if you create it right there inside that start method or whatever, it knows that the very next line that tries to use it can't because it doesn't exist yet. So you'll get this error depending on where you actually create this object, this allocation. But if I then instead undo that, give myself the candy object, now C is perfectly fine. So just be aware that it can vary depending on where you create this stuff. Okay, so just going to turn this start back off, turn that candy off. Okay, so let's do one more start. And notice, as I said before, it gives me the private by default. So just going to get rid of that. And I am currently ignoring all the formatting changes Visual Studio is doing to the rest of my code above this. So yeah. So now, as we saw earlier, when we constructed both integer arrays, string arrays, that kind of stuff, we use those curly brackets. So in this case, I want to create an array of those candy objects. Now I'm going to say candy, square brackets, A, because it's an array, candy bucket. Okay? Now, when I allocate this stuff, I want to allocate it one time. If I come through and allocate it a second time, third time, I overwrite what was there. And so any manipulation that I've done to the content of this array basically gets stomped on. The memory gets all kinds of wacky because you're basically asking the system for memory, and it can bog down the program. So the idea is I want to do the allocation, the creation of this array inside my start, but then maybe later on I want to do any kind of manipulation right there inside update, right? You don't want to do this creation every single time in update. So just something to be aware of. So here inside start with this variable name, a candy bucket, I'm going to go ahead and say that I want a candy bucket equal to a new candy. This is just like saying int brackets, new int brackets, same kind of thing. And in this case, I don't want to give it any kind of count. I want the system to do the counting for me. And then after the square brackets, I want to add my two curly brackets. Now, remember from way up here when we defaulted like each one of these things to some value, we went through and we constructed here using the curly brackets to give ourselves those individual items, and then we separated them with a comma. Well, those are integers. They're perfectly normal just to have the number right there. However, when we're dealing with these more custom types, I can't just say, quotes, Snickers, and then some number. I can't just say some way of directly accessing it. Because again, just like when I created that candy C object, the object has to be allocated. You have to ask the operating system for the memory to be able to construct this thing. The same thing with the string array that we created earlier. You saw I asked for three strings, but then inside each of those three strings, they were null until I assigned them. In this case, I need to actually say, I'm creating a candy bucket. It's going to have some number of candy objects inside it, but I need to also allocate those candy objects. So in this case, I need to say new candy, and now inside the the constructor's parentheses, I can actually say what kind of candy objects I'm dealing with. So in this case, I'm going to go with Snickers, and let's say 5 of those. Okay, and now for the next object in my list, just like I did with those integers, I do a comma, not a semicolon. I'm not ending this line of code. I'm still working on it. So comma, and now for the next one, I want to do new candy, and let's say nerds. And let's say I have 4 of those. And finish it off with new candy, and let's go with Twizzlers. I don't know how to spell Twizzlers. Z? I don't know. Whatever. Let's go with lollipop like we did a second ago. Okay. And let's just say that I have, whoops, not there. There. Let's say I have 6 of those. And now that I've completed my list internally, I don't have one more object, so I don't need that extra comma right there at the end, okay? But I am done with this whole initialization, allocation, and assignment line, so I do need a semicolon at the end of it, okay? So now I know for a fact that every one of these candy objects is capable of printing out its own internal information. So I could go through and I can do a couple of things. One, I can run a for loop across this and ask using the properties for all of their information, or I can just say for each one of the things that I'm accessing, tell it to report its contents. So if I do a for int I equals 0, I is less than the a candy bucket dot length, how many candies are we dealing with? Then I plus plus. And inside these curly brackets, I can either say debug.log, name, and let's access the a candy bucket sub I dot name plus a space, and let's say count equals, and again, a candy bucket sub I dot count to access the property. So now this one line, if I go ahead, save, jump back to Unity, and run this, you'll see that it dumps out those 3 candies and their count, their name and their count, on 3 separate debug prints. I could also, let's just jump back to the beginning of that line, comment it out, jump to the end, hit new line, and just say a candy bucket sub I, whichever one we're currently talking to, dot report contents. Now it's going to defer the logging information, the logging action over to the other side. It's going to call it from its other location. So now if I save this, jump back to Unity, and clear this so we make sure that we don't have any kind of other, because it's going to look the same as the last one, but print, or rather play, and we get the same information. And just double clicking on that takes me back to, in this case, where that information originated from. This actually came from candy. It was invoked by the report contents being called inside this array, but where it actually came from was over inside candy. So now I'm going to stop playing. And let's see here. I believe that, yep, that wraps everything that I wanted to talk about regarding array creation syntax, creating your own custom types, how to allocate, get space from the operating system or from the environment you're working in to create those things, how to assign them using the constructor's incoming parameter list. You can also use those properties to both get and set so that you're not, to the outside world, you're not dealing with your private information because you want to keep that private. You can also use those properties to do sanity checks, variable checking. You sanitize the information coming in, making sure that you're not accidentally changing some general gameplay rule accidentally. Let's see. You saw how for loops can iterate across there. We talked about initializing values directly inside the parentheses for the scope. We talked about the 3 different parts that make up the internals of a for loop: the initialization, the condition, and the update. Yeah, so that's basically it for this lecture. Any questions, comments, concerns regarding this content from anybody here in class? I'm going to look at the chat. Yeah, Ben, if you, let's see, 6, 19, depending on where you created that Candy class, it could definitely impact. Like I demonstrated it being outside into global space because the system didn't understand, or the system didn't know ahead of time where that variable was going to be. So it just said, I'm gonna wait for you to do the work. And if you don't do the work later on, that's when you run into that null reference exception. But if you then create it right there inside that method's scope, inside start, or anywhere else for that matter, if it's right there next to it and the compiler has enough information that it can see, hey, you've created this, but you've not allocated it, and then you try to use it, then it can jump in and explode. So these are different things that, generally speaking, just as a kind of a general bit of advice to you guys here and in the chat, Unity, the compiler that it's using, Visual Studio, that kind of stuff, they're smart to a certain extent. They can look at your code and, like, if you throw a return in there, it's going to give you a little warning saying, hey, I can't access anything after this. You'll get a warning in Unity saying, from this point down, the code is unreachable. Now, you can also write code that if the system, when it compiles, if it looks at it and says, this code never actually gets used, it can automatically remove that from the final binary that actually gets run. So you can run into scenarios where you're trying to test something, and, like, for example, when I very first started and I showed you guys the debugging stuff, I put a debug log after that line that I knew I wanted to inspect the array. I put that there because I knew that Unity or Visual Studio or the compiler or whatever would possibly remove that line because it didn't do anything. There was no other usage of that line of code after that. And so to basically force it to do what I wanted it to do, I added that debug log and put a breakpoint there. I put a breakpoint a couple of lines up. That way I could step into it and you could see it before allocation, the array was null. After allocation, the array was 3 large, but the internals were null. And then you saw what happened after I assigned them. They became useful values. So some of this stuff, it's just useful to keep in the back of your mind that as you're debugging this stuff, just in general, as you're building your stuff in general, the tools might step in and try to, like, optimize for what's going on. Because as far as it's concerned, it doesn't know that you're experimenting. It doesn't know that this isn't a production app that you're trying to pump out to an app store. It's just doing what it has been told to do best, and that's, like, optimize the code for a final release or whatever. And so sometimes you have to step in and kind of change some settings or tune it a certain way, maybe just for a one-off test, but then just remember to go back and, turn those things off if you turn something on or whatever, change it back to its original values. But for all intents and purposes, it'll give you all kinds of information. There are those edge cases where it won't, and it's useful to be aware of why. So, those around you, your peers, your classmates, future tech leads, that kind of stuff, they'll hopefully know this kind of information. So if you run into it, it's like, oh, hey, I remember Professor Reynolds talking about this. It was a one-off, but there it is. So you can potentially use it later on. Then there are other cases where you may never run into this ever. But it's useful to know because you will potentially run into it. Some of Unity's own examples can run into this kind of stuff, and they'll mention it to you, like, as they're doing their live trainings. So just keep all those different bits and pieces in mind as you as you tear through this. Just realize that the computer, there's no magic to it. There aren't ghosts in the system. Halloween. It's doing exactly what you told it to do, and save for any kind of like weird hardware anomaly or weird software anomaly, it's going to do exactly what it's been told to do. But it can also, between the time that you write the code and you run the program, between that window, there are other steps that the compiler's doing, the optimizers are doing, so on and so forth, that might modify the code differently than what you thought you wrote. And so it might run slightly different. This is why we always talk about play test this stuff, run it through a battery of tests, try to get this stuff working. I'm actually going to end the recording.